So good evening, everyone. Let us start today's session. So can you able to see my screen?
Yes, ma'am.
Okay, thank you. Okay, it's a recap of yesterday's session. So array of structures and structure of arrays. So here in this program, you can use array of structures for CPU for getting better locality and structure of arrays for uh, GPU for getting better collision. Now what is collision and all? So here in this array of structure, after all the data members in one structure, so the next structure node will be stored. So here in this, each and every one is one of the every one value of each and every data member is stored sequentially. Okay, so if you use structure of arrays in GPU, you can get better policing and it will speed up the program. Okay, so I'll execute the program in policing. Okay, so already I think I have executed that program. Okay, here this is a program. It's written. Already in the last class, you have explained this one. Okay, for getting collision, so what it has done is some array is given, then you are having some size of that array. So we are starting the threads. After that, we are assigning values of that thread numbers to an array. So if you want, you can print it and all. So this is just simulating the collision concept. So here we are not printing anything. So it's written. It is working. Okay, sorry. What happened is first we have to do this. After that, we have to write into file. Otherwise, you'll get this type of error. It's executed. So I am simply printing some message that is printed here. Okay. So if you want, if you get inputs and so you copy all the data A from. Okay, there is no need of getting input and all here in this program. You copy the resultant array from GPU to CPU, then you print. Okay, that's enough here. If you want, you can modify. And this memory collision and another one program. Wait, I'll copy that program. So yes. This AOS. Yes, yes. So it should be device synchronize. Can't use thread synchronize. How many device synchronize? Some more are available. Okay, so anyhow, we'll execute. Let's see. Okay. Here, array of structure. It takes 0.0041 seconds. I can convert it into milliseconds or microseconds and all. SOA time, it is 13 seconds. Okay. So likewise, you can calculate the time too. Okay. The time calculation part is there in this program. So if you are executing some concept of some program in the OLAP, that time you use this time, and you can say your code or your implementation gives better time. Okay, all this already we have seen array of structures and structure of array. Then the kernel is written and the value is just calculated, ID is calculated and it is assigned. So also SOA part. So simply some assigning values happened here. Okay, that's all. Then we are doing CUDA MLOC for assigning that is allocating space for those variables in the GPU. Then we are the kernel is launched. Then you have to what we have to do. We have written two kernel, no? So both the kernel has to be launched separately. Okay, after that, so you get the result, then you print all those things. Okay, and here the results are not getting back, just it is executing and printing the type. If you want, you do that. Okay. Okay. Here the SOA time is very less. We'll come back to AOS time. Okay. So already we have discussed these two, and in array of structure, we are having the data is stored in this manner. In structure of arrays, it is stored A1, A0, A1 up to AN minus 1. After that, the next variable values have been stored. Okay. So next we will see what is shared memory. So L1 cache, so it is having the shared memory. So this particular shared memory is mainly used by the all the threads within that particular block. Okay, so which is accessible only in a thread block. Okay, we couldn't access in the another thread block, and so see, if you are having small amount of data, you can go with this type of shared memory. So you can declare variable in this way. Shared, so you can use any type of variable, any data type, and shared unsigned, yes. Okay. So you can assign the values to that shared variables, and if ID is equal to 0, there is some condition, something is given. Okay. So we'll see what happens while doing shared memory. Okay. So in shared memory, in the sense, our code will be executed in a single block. Okay. So it works on a single block. You see some programs. Okay. So what is this? Shared memory programs. See here. So we are having the first program. Uh, Here there is one variable, one unassigned variable is used. Okay. So then we are using only the threads. Okay. So we are having only one block. Then we are launching with some threads. Okay, the thread size is given as 1024 for each block. Okay, so even though we are using only one block, so next some conditions are there. If thread idx equal to 0, s will be 0. Thread idx dot x equal to 1, and s is incremented by 1, otherwise 2. And if thread idx dot x equal to 0, then what happens is it has printed some value too. Okay. So what happens, we'll see. So here some kernel is launched, then we are synchronizing the device. Okay. So I will return the program, then we execute. So we'll be getting s equal to 3. Okay. See here, s equal to 3. What happens here? Kernel, there is no upper limit and all. Incremented. Again, it is incremented. Okay, initially thread value will be 0. After that, the thread value will be 1. So after that, the thread value won't be 100. Okay. And so after that, what happens is thread is incremented to 2. Okay, 0, 1, 2. Likewise, it is incremented. So it is incremented to 2. And 1 plus 2, that will be 1. Okay. So next, the thread value is printed here. What is there in the thread? That is printed here. Okay. So what happens is thread is incremented to 3. Okay. So we'll see in the next program. Okay. Actually, this is not our main part. What happens where we are using shared memory concept in a CPU, GPU program. Okay. So in the next one, everything is same. We are using only one shared variable here. So here, two blocks have been used. Instead of one block, here two blocks have been used. Okay. So for launching the kernel. Okay. What happens while launching threaded DX with two kernels, two blocks? In the both the blocks, the same code will be repeated. Okay. Same instructions will be repeated in both the blocks. Okay. So it is written for the previous program and this program, the change is there in the kernel alone. It is represented as one block, number of block, it is 2. Okay. So already I have executed this one. Okay. So for first block, S is 3, and the next block again S is 3. Okay. So likewise, it will be printed. Okay. So on the next program, we'll see the next program. So I want you to execute this program. Just a minute, I will paste it in chat box. Okay, so if anybody want to execute, just execute and paste the result in the chat box. Okay, so this is the first one, only one block. So this one is the next one. Here we are having two blocks. So both the blocks are executing the same thing. Okay. So I have pasted both the programs. Okay, we'll see the next one. So in the next program, we'll see it here first. See, same code, everything is same. So, but there is only one change in the main function. Okay. So it is called within the kernel is launched within a for loop. Okay. So for 10 times. Okay. So you can use it for, I have executed that one. So initially we'll put here one, only one block. See what happens. Okay. Okay. So without for loop, you are getting one. So if you have executed for 10 times, same kernel is launched for 10 times. Sorry, I have to compile. After that, run the program. Okay, so we'll be getting 20 times. Okay, because we are having two blocks. So already we have seen this one. So anyone is executed that program? No, no one is executed. Okay, no issues. I'll paste this one too in the chat box. Okay. Okay, so the next program also there in chat. This is a program for thread divergence. So already we have discussed this program in the last class, thread divergence. Okay. So here in this program, we are having kernel and what happens here? So there is some conditions are there. Okay. So if it is like that, if ID is mm, what we can say this even number, so simply assign the value. Otherwise, you have multiplied. You see here, the value is changed in each and every thread. Okay, so you can see the difference between this program and the shared memory program. Okay, in shared memory we are getting all the values, all the same values. Okay, if there is some divergence is there, that time we won't get the same values, we are getting different values. Okay, this is the thing. Okay, so on the next one, so we have this seen this one from current slide. Okay, this same one, same one. Okay. So next, how we can synchronize threads. Okay, anyone executed the program? I think this is one way. Okay, no problem. So I'll upload the notebook you in the sheet. You try to execute later. Mm, we'll see the next one. Okay, so here again we are using shared memory. Okay, so next we are performing synchronization. Okay. So during synchronization, what happens? You know that at the same time, more than one threads can execute. Okay. So what happens is, okay. So we'll see what happens while executing this program. So there is nothing changed in that particular program. So only one change there is uh, after each and every what is that thread condition. Okay, so one sync thread is given. We'll see what happens while executing this particular program. SY, the file name. Here also put SY. No problem. Yes, and then here. Yes, something. Okay, nothing has happened. Actually, There are two blocks have been used here. We'll see what happens while doing a single block. Okay. So all are same things because here we have used the for loop for single block is equal to 3. So, so instead of using 1, you can use 2 here, and so everything is executed twice. The next one. So we are having another one program. We'll see what is the output of this particular program. See here we are having one kernel program. Okay, so inside that we are having one shared variable str of block size plus 1, that is a single dimensional array. So next we are calculating all the thread values, then it is stored on the particular shared array. Okay, so here we are given a plus thread idx dot x plus block idx. So percentage block size. Okay, so all those things are there. And if thread idx dot x equal to 0, str of block size, it is assigning some value null. And so here the thread idx dot x and the block idx dot x both have been added. And if thread idx dot x equal to 0, so you can both the times same condition has been given. It will be printed. Okay, see what is the output of this one. One, two, three, four, five, six. Ah, sorry. Thousand before. It is some value. because of that big block size. So you're having so many garbage values. Okay, I am reducing that size. So we'll see what happened. Okay, so I am again reducing. Don't I think cell is already running. Oh, right. So if you have given more values, what happens? All the remaining place you are having the garbage value. Okay. So here str of thread idx dot x a plus some value. Okay, that is added and you'll be getting the character values for that corresponding character value. Okay. So the end of the array has to be filled with end of string, that is null, you know that. So again, if thread idx equal to 0, so we are printing block idx dot x, comma, what is there in the string. Okay. So the block is having values, these values, and the string is having these values. Okay, here we are using 8 blocks. See here, I have used 8 blocks and 10 blocks, and each block contains 8 threads. Okay, so it is using some random value. So if you have given some value, automatically the GPU will take and it will give some result. It won't worry about whether it is there in the number of threads and blocks. Okay. So which will be executed first will be stored there, displayed in the at first. Okay. So we haven't given any synchronization and all. So there is no sequentiality and everything. Okay. So here in this particular program, if you have given sync threads, okay, so what happens is here, say the same program, see here, uh, we are having the block size and the block ID and the str. So the str contains the values of threads. Okay. So what is there in the thread, that is the here stored in the array str. Okay. See here, uh, based on the availability of thread and block. So the particular thing is printed. Okay, what we are storing, that is printed. There is no sequentiality is there. So we'll see what happens while executing the next one. So already I have executed so many programs. If this is pasted on the, yes, after that, this. Okay, I'll paste this program alone. Okay, so next we'll see the next one. So here we have included one more statement, that is sync threads. We'll see what happens. Same problem. Okay. Okay, here we have given synchronization threads. Here we didn't given synchronization thread. Okay, and both programs have given almost same result. Okay, so you are having uh, 10 blocks. How many blocks says each block contain 16 threads? Okay, no problem. And so if you have given sync threads, it is a barrier across the threads in a block. Okay. So again, we are not getting anything. So if any thread is getting the value or executed first, that will be printed first. Likewise, it goes on. Okay. The main issue here is so the synchronization barrier enables multiple threads and wait until all threads have reached a particular point of execution before any thread continues. Okay, so this synchronization barrier is not shared among across the processes for different threads in our case. It won't be shared. Okay, so that is the problem. Okay, so we are getting the same thing here in this program too. And these are some of the programs there. Okay, let's see. So we'll execute some more programs and so one or two programs. Here this program that is one dimensional. Already you know that single dimension. So 5, 6 is given and memory is allocated. Then CPU memory is allocated, kernel is launched, the matrix is passed, and okay, the input is not given. See what happens. Okay. So already we have seen this program. So that is written in some other way. So to print all the things, what is there in the so matrix, the single dimension. Okay. And here we are ID is calculated based on uh, block IDX in the block dimension. That means number of threads in that block plus thread IDX. Okay. So in double dimension, what happens? Okay. So there is only small change. Okay. So the threads, the block dimension and thread ID both are in the y direction. All the remaining are same. So again, you have to do one more change. So you have to specify the dimension. Okay. So n comma m comma 1. Okay, that is assigned as the number of threads. Okay. So already we have calculated. So 5 into 6 into 1. So and each block will contain 30 threads. CUDA program. There is some error now. Oh, yeah, here. CUDA program. Okay. Okay, same thing. Okay, already in another one class, I told that either it can use 2D or single dimensional. So it can able to give you the same result. You can go with the single dimension. If your data is two dimension, you can write the 2D program. Okay. So another, this is something different program. So we have this two more. Yeah, two more in this class. Okay, so I'll explain first. So here, if any kernel program that start with that has to be start with the global keyword. Okay, so this particular function is called as kernel. Okay, this is not kernel program. So it is executed there in the host. Okay, so double underscore host double underscore and space. You are having the device and void function. Some counter is incremented. Here, this program alone is called a kernel. This, if any code or any function start with the host is our CPU. Okay, that is will be executed in the CPU. Okay, then you have to allocate host allocate, CUDA host allocate function. So after that, you will launch the kernel, then you do all the remaining things. The function fun that is called here. Okay, you can call that function here. Okay, once kernel launch is over, so it is called here. After that, it is printed. Actually, this function will be executed there in the CPU, not in the GPU. Copied. No. Okay. Go there. 21. see. So here we are using only one counter value. So this fun is also called there in the kernel program. Okay, so you can call it here. Okay, then what is the value of counter that is printed there? Then here we are having again one variable that is passed. Then counter is incremented to assigned to 0. Then that in the main function, what the value of count, that is C here, that is 0. The main function, it is 0. So execution starts from here only. So initially 0, then goes to GPU. Okay. So here while going to GPU, what happens? So this kernel is called fun of counter, that is incremented. So then after that, that is printed. So it is 1. Okay. So then it's come back to GPU. Again, the fun is called. Okay. Now counter value is 1. And after that, what happens? It is incremented. Then it is while printing that counter value, you will be getting the value as 1. Okay. So in this way also you can write CUDA programs. If you write a function, you can call that function both there in the CPU and GPU. For that time, you can write in this way. Okay. Same function. If you want to execute a same function there in CPU and GPU, that time you can write in this way. And one more is available. Host and device. So here you are having some array, the host device function, some array. So it is having a for loop and it is incremented and stored it in the array. So after that in the kernel program, again that function is called. So again we are having one more host device function. So that means it can be executed there in CPU and the GPU. Okay. So here again we are having some assigning and that value is printed. So next that array is called. Okay, see here. So you can use CUDA malloc2 for allocating space in GPU and the array is passed there. So again one for loop is used. Okay, and the data is passed from host to device. Then the function is called. So after that, the kernel is launched. Okay. So You're having only one kernel or two kernel? Two kernels are there. Okay, first kernel is launched first. So after that, the second kernel is launched. Flash. Okay, so this is the output. Here that is printed. So here it is not printed, and here it is printed. Okay. See here, simply array is having some value and executed there in the main. Okay. First, the array is assigned with the value 0 to up to n. The n is assigned as 10. Okay. So after that, that array is passed over there and kernel is launched. Okay. And defun 1 comma 1 d array. Okay. So here, what called the fun array is called. Okay. So after that, it returned back, the array is printed. Next, dprintf is called. In dprintf, you are again printing. Okay, the same array. Okay, that's all. So we are getting the same values in the both the things. Okay, so this program is just a simulation of how we can write more than one kernel and more than one host device functions. Host device function is, so a kernel function is the function we can execute only in the GPU. The host device function is the function we can execute both in CPU and in the GPU. You can call over here and there. Okay. So any doubt?
No, ma'am.
Nothing. Okay. So it's done. Okay. So I'll share the notebook. We'll go through the programs and execute. So if you change somewhere here and there and try to modify the programs according to your requirements, then execute, then you will learn more about your GPU programming using CUDA C. Okay. So thank you. Thank you all.